Let's take a few notes on position time graphs. This is in reference to the lab we did on Thursday. So one of the first things you should have noticed about the lab is that when you were going slow, you had a low slope. When you were going fast, you had a steep slope. So we can equate that observation and put it into words. There must be some relationship between the slope of a position time graph and the speed that you're going. Let's look for another relationship. The other thing you might have noticed, let's have you going back slowly, and then when you stopped, the position did not change. If the position did not change, there was zero slope because you're staying at the same position. Duh. So if there is zero slope on a position time graph, it means you're not moving. It also means, if you're not moving, that you have no speed. So there's a direct correlation between no slope and no motion. The other thing we could have noticed is as you walked back towards the motion sensor, the line went like that, which gives us a negative slope. So it turns out that a negative slope means you're moving back towards the motion sensor, and the motion sensor was simply your origin. So you're moving back towards the origin. Negative slope is towards the origin, and that means that the positive slope was away from the origin. And of course, back over here, where there is zero slope, you're not moving. So the slope of a position time graph has a direct correlation with the speed you're going. If it's got a big slope, you're going fast. A small slope, you're going slow. And also the sign of the slope of the position time graph correlates to the direction you're going. If you have a positive slope, you're going away from the origin. If you have a negative slope, you're going towards the origin. So there's three definite correlations. Slope has a direct relationship with how fast you're going. Sign of the slope corresponds to moving towards or away from the sensor. Zero slope, not moving. We can get more specific than that. If slope has a direct correlation with how fast you're going, let's take a look at the units that you have on that slope. Slope we know is rise over run. Well, on the rising side we have position. The units for position is meters. The running side we have time. The units for time are seconds. So we have rise over run. That gives us the units meters per second. That gives us our first hint, because meters per second, of course, is the units for speed or velocity. So that gives us our final correlation. Okay, the big important reveal, the drum roll. It turns out the slope on a position time graph is the velocity. That is critical. Thank you very much for your time.